Welcome to my first course on differential equations. In this course, I will be considering ordinary differential equations. A differential equation is an equation containing derivatives of a function. For example, dy dx plus y equals 0, where y is some function of x, is a differential equation in y. The goal of differential equations is to obtain the function y which satisfies the differential equation. In our example, that means we need to find a y such that the sum of its derivative and itself equals 0. Because y is a function only of x, we don't have partial derivatives of y with respect to x and perhaps partial derivatives of y with respect to some other variables, say t, if y was a function of x and t. In that case, if y was a function of x and t, we might have partial derivatives with respect to x and perhaps partial derivatives with respect to t, or perhaps partial derivatives with respect to both x and t. And we'd have a partial differential equation, or PDE, rather than an ordinary differential equation, or ODE. So this one here is an ODE. This is an ordinary differential equation. And this is what I'm going to focus on in this course. Ordinary differential equations. This particular ordinary differential equation is a rather simple equation. It's a first order differential equation because the highest derivative of y that it contains is its first derivative. There are no second, third, or higher derivatives. If it contained a second derivative, it would be a second order differential equation. If it contained a third derivative, it would be a third order differential equation. And just to clarify, the order of a differential equation is determined by the highest derivative in that equation. So, for example, if we had the fourth derivative plus we can include coefficients in front of the derivatives and the function itself. So maybe we might have x squared times the third derivative. And the coefficients don't have to be constant either, they can be some function of the independent variable, x in our case. Plus y equals, and we can have some other terms involving x or constants here as well. So we might put this function here, x plus cosine of x. So this one here is a fourth order differential equation because its highest derivative is a fourth derivative. Also, both of these equations are linear differential equations because they are linear in y and its derivatives. They do not contain, say, y squared or cosine of the third derivative. They do contain cosine of x and x squared, but that's okay because they're linear. It's a linear differential equation, which means it's linear in the dependent variable, which in this case is y. It's linear in y and its derivatives. That means it's a linear differential equation. Okay, so both these equations are linear, and this one here is first order, and this one here is fourth order. This first one here is also homogeneous, and this one is non-homogeneous. This one is homogeneous because it only contains terms involving y or its derivatives. This one also has these other terms. So if it contains some other terms which are just the independent variable, or functions of the independent variable, or constants, these make it not homogeneous. Non-homogeneous because it contains not just y and derivatives of y, but also some other terms. So this doesn't make it not homogeneous. So we could have that equation without this term, and then it would be homogeneous. So if we had fourth derivative plus x squared times the third derivative plus y equals 0, this would be homogeneous. Whereas this is not homogeneous. Some more examples of homogeneous equations would be dy dx plus xy equals 0. So we can add terms in front, add coefficients in front of these terms, and it will still be homogeneous. It's only if it contains some other term that's not y or its derivatives that it becomes non-homogeneous. So these are all homogeneous here. Term this, and we could have dy dx plus sine of x y equals 0, or we could have the cosine of x times the derivative plus y equals 0. And these are still homogeneous. But if we had cosine of x dy dx plus y equals 10, then it's no longer homogeneous because it contains some other term. Or if it contained 10 plus x squared, it would not be homogeneous either. Now, this equation here and this equation here are actually related, because this one here is actually the associated homogeneous equation of this non-homogeneous linear differential equation. So this equation, the left-hand side of both are the same. The only difference here is that this one here has this term, whereas this has just got 0. And later on, you'll see that the associated homogeneous equation of a linear differential equation is important. We'll cover that later. Okay, so I've explained a bit about different types of differential equations, ordinary differential equations. Remember, the goal is to find some function of x such that the differential equation is satisfied. That is, that the right-hand side equals the left-hand side. So for this first one, we need to find, as I said before, a function for which the derivative plus itself equals 0. So in this case, this is actually fairly easy. All we have to do, the solution looks like this. Y equals exponential of negative x will solve the equation, because the derivative is negative of itself, which means that dy dx plus y equals negative e to the negative x plus e to the negative x, which equals 0, which solves the equation dy dx plus y equals 0. Yeah, here. Dy dx plus y equals 0. So, as I've shown, exponential of negative x solves that equation. The derivative plus itself equals 0. Also, any constant multiple times this solution will also be a solution. So y equals e to the negative, say 5 e to the negative x, or y equals 100, or any constant multiple. Y equals negative 1000 e to the negative x will also solve it. Any constant multiple, so the general form of the solution would be y equals c, some constant c, times e to the negative x, where c is any constant. And that will always solve this differential equation, this one here. In future videos, I'll talk more about how to solve differential equations.